In this lecture, we're going to study about IP gateway and router configuration. Now, IP network requirements. Configure the gateway, the routing table to support the following network setup. Basically, we're going to learn how to set up an IP routing table through an actual experiment where we actually set up based upon network requirements. Think of it like this. Room A, B, C, and D these are like computer rooms, computer labs. And we need to set up a router where we can connect all these PCs such that these individual computer labs can all have access to each other as well as send and receive packets through the internet. For our gateway, we're going to assume that we have 4 ports that we're going to use. Now, a larger gateway could have, of course, more ports. However, it has 4 ports that we're going to use, and it's going to be port 1, 2, 3, 4, as you see right here, where for room A, there's 100 PCs inside, and we're going to connect port 1, the interface 1 of the gateway to it. For room B, there are 25 PCs inside that room, and we're going to connect that to the interface 2 of the gateway. And then for room C and D, they're connected to a switch or a hub right here, and they each have 25 computers inside. They're connected to this switch or hub, and then that is connected over there to interface port number 3 of the gateway. The internet is connected to the interface number 4 right here, as you see below. We're going to go and set up that routing table that's in the middle of the gateway, the router. And by that, I think that you'll have a real good understanding of the subnet, IP addresses, and the other configurations about how the network, how the internet actually works. So here we go. First, we're going to subnet the IP network. And like I said, we have 4 rooms, A, B, C, D. And we're going to subnet off of this, which is 165.132.9.0. And we're going to use 256 IP addresses to do that. That's what was given to us by the network administrator. Now, the gateway connects these 4 rooms and the internet. In addition, room A has 100 computers and connects to interface number 1 of the gateway. Room B has 25 computers and connects to interface port number 2 of the gateway. The rooms C and D connected to a hub and switch, each having 25 computers each, and they connect to interface 3 of the gateway. And all PCs need to have connection and internet access, and that is connected through interface 4 of the gateway. And the internet connection that we see has a port connection where it is 165.132.15.56 with a subnet mask of 255.255.255.252. And the subnet mask is also called the net mask. Now, for this configuration, given the information of the IP address to use and how many addresses we were given to subnet off of, well, the range that we get to use is this. Basically, from 165.132.9.0 all the way to 165.132.9.255. From 0 to 255 is 256 IP addresses. Now, we're going to look into subnet for room A. In subnet for room A, we said that we had 100 computers, and each of them need an IP address. So I need 100 IP addresses. In addition, you will see that for this subnet of room A, you also need a network destination, an IP address to represent this subnet altogether. And basically, so therefore, I need 1 IP address for that. In addition, for this entire subnet for room A, what I also need is I need 1 IP address to be used for broadcasting. So therefore, if I need to send a packet to all of these IP addresses, all of these interfaces that are in the subnet for room A, then I need an address for that. In addition, I also need an address, IP address, for the gateway's interface number 1, which this room is going to be connected to. Because it's an interface, it needs an IP address assignment. So therefore, these are the IP addresses that I need. Add them up together, there's 103. Now, I'm going to look at the subnet size, and this is where we look into some number comparing. I need 103 IP addresses, and the subnet sizes are always 2 to the power represented numbers. In other words, 2 to the power 1, 2 to the power 2, 2 to the power 3, and going up and up and up. Now, I need to find the smallest subnet size that can fit in 103 IP addresses. If you look that up, the smallest number is 2 to the power of 7, which is 128. It's a lot larger than 103, but it's still the smallest number. If I go to 2 to the power of 6, then I cannot contain 103. So therefore, 2 to the power 7 is the number I have to use. It's a lot larger than 103, and we'll soon see the effect of what this means. Now, if you look at the subnet mask here, then 2 to the power of 7 is what we were going to use, which is 128. 2 to the power of 7 means that the subnet mask will have, the 32-bit subnet mask will have the last 7 bits assigned as 0, and the rest will be 1. So therefore, the subnet mask will be 255.255.255.128. Now, for these IP addresses, what we're going to do is, the lowest IP address will be assigned to the network destination. The highest IP address in this subnet will be assigned for the broadcast IP. The second highest IP address in the subnet will be assigned to the gateway interface number 1. Now, if you look at this structure, as you can see, well, the IP address for room A will be off of 165.132.9. That star right there. Now, what's going to go into that star? Is that. These are the numbers that are going to go into that star position. The 0, which is the lowest number among the range of numbers I have, will be used as the network destination. Then, I had 100 computers from 1 to 100, so I'm going to use 100 IP addresses, 1 for each PC. And then, I'm going to go to the bottom right here, the broadcast IP. I'm going to use the highest number and assign that to the broadcast IP address. And then the second highest one will be used as the gateway interface number 1 IP address. Then, in the middle, from 101 to 125, in what you see as this underlined gray numbers, well, these are the IP addresses that are reserved for future use. You can assign additional computers using them. However, if they're not assigned, then yes, they will be wasted. This is why subnetting makes the internet extremely scalable and very, very effective and efficient to manage and operate. However, the subnetting architecture does result in some wasted IP addresses. Next, we need 103, but we got 128 as the subnet size that we could use. And therefore, the subnet size was assigned like this. Now, there is a notation called CIDR, which is classless inter-domain routing. And this technology gives an assignment mechanism where we can write up the network destination and the subnet mask all together in one notation. And that is what you see right here. In other words, the network destination is the address, which you see right there, 165.132.9.0. And then the subnet mask, how many ones were in the subnet mask? Now, we already said on the former page that there's going to be 7 zeros in the subnet mask. Since it's altogether 32 bits, that means that there are 25 bits right here that are all ones that are in the subnet mask. So therefore, we will represent it as with a /25, as you see down there at the bottom. That is the CIDR notation for this network. Now, let's go to subnet for room B. Room B had 25 PCs inside. So, one IP address for each computer. Here we go, 25 is needed. We need a network destination for the subnet of room B. We need broadcast IP address. We need a gateway interface IP address for interface number 2 of the gateway. Now, so therefore, altogether, I need 28. Okay, what is the right subnet size? Here we go. I need a number that is larger than 28, but I'm looking for the smallest number that will fit in 28, but is also a number that can be represented by 2 to the power of a number. And that number is 2 to the power of 5, which is 32. 32 is larger than 28, so it fits it well. Now, representing that in a subnet way, 2 to the power of 5 means that the subnet mask, 32 bits, will have 5 zeros at the end. So therefore, the subnet mask will be 255.255.255.224. And the lowest IP address in the subnet will be assigned to the network destination for room B's subnet. The highest IP address in the subnet will be assigned for broadcasting IP to all the IP addresses in room B's subnet. The second highest IP address will be assigned to the gateway interface, number 2. Now, based upon this, you can see that the IP addresses assigned will be off of 165.132.9. That red star, and the number that we're going to put in that red star is these numbers right here. The lowest one is 128 because from 0 to 127, we've already used that for room A, that subnet over there. So since we used that number, we need to start from 128 here, which is for room B. So we start with the lowest number, 128. That's the network destination for this subnet of room B. And then for the 25 PCs, we assign one IP address for each one of them. So that's going to consume the last numbers of 129 to 153. And then the highest number is used for broadcasting. That's 159. The second highest number is used for the gateway interface IP address, port number 2 on the router. So we need that. Then, once again, well, I needed 28 IP addresses, but the subnet size that was assigned was 32. So unfortunately, well, I have 4 unused IP addresses that are reserved for future use or maybe wasted if they're not eventually used. Now, the CIDR notation used can be represented like this. Once again, the number of ones in the subnet mask is 27. So therefore, using the network destination address that ends with a .128, it goes down there, which is 165.132.9.128/27. And that's the CIDR network ID notation. Then we go and we look into room C and D. First of all, C and D each had 25 computers each. Add them up together, that gives us 50. So I have 50 over here, and then likewise, for room C and D combined together, their network destination will need one IP address. The broadcasting will need one IP address for this specific subnet. And also, the interface on the gateway, which is port 3, will also need one IP address. Once again, every interface, every communication interface needs a separate IP address assigned to it. So look at the router. All of the interfaces need individual IP addresses, and that's what we're preparing. Combine them all up together, we get 53. Now, what is the right subnet size? Once again, the subnet size has to be represented as a power of 2. So 2 to the power of something. So what will fit 53? What is the smallest subnet size that will fit 53 inside? And that will be 2 to the power of 6, which is 64. So 2 to the power of 6 means that if I look at the subnet mask, the 32 bits of the subnet mask, the last 6 bits will be the zeros. So therefore, the subnet mask will result in 255.255.255.192. Those 6 zeros at the end are opening up the mask so that these ranges of IP addresses can be filtered, can be masked through by this. So what do? Well, basically, the network destination and the subnet mask will give the range of IP addresses that belong to this subnet for room C and D. Now, the lowest IP address in the subnet will be used for the network destination for the subnet of room C and D. For room C and D to broadcast on this subnet, I will use the highest IP address. And also, among the numbers in this subnet, I will use the second highest IP address for the gateway interface number 3. Now, the numbers will be assigned in this star once again, and the numbers are these numbers right here. So the network destination is the lowest number. I start at 160 because what I did was up to 159 was used by room A and room B. So I start with 160 from here. 160 is the lowest number, so it's the network destination address used for this subnet of room C and D. Next, I had 25 and 25 in each room, so these two combined together are 50, so I'm going to use 50 IP addresses for each of these 50 computers. In addition, I'm going to use the highest address for broadcasting, the second highest one for the gateway interface number 3. Then, in the middle, I have 11 reserved, this gray underlined range of numbers. They are unused. And once again, they are reserved. That's a good way to put it. On the other way, if they're not used, well, they're wasted. And we can see, why is this? Once again, it's because we needed 53, but we had to go with 64. So therefore, that resulted in these many 11 IP addresses that are contained within this subnet that are not used currently. Now, we may need to assign an IP address for the hub, the switch, in some cases. In this example, it was not required, so therefore I didn't. But in some cases, we may need to. In that case, then, as you look right here, the highest IP address was for the broadcast. The second highest one was for the gateway interface, port number 3. Then another one, among these 11, the next highest one, I will assign that to the hub or the switch. Or the hub may be the switch. Well, whatever it is for them. If I needed 2 coming in from each side, then I will use 2 among these 11 that I have right here. I have these left over, and I'm not using them, so I might as well use that for them, if the switch needed it. Now we're going to go into the IP routing table in the next lecture. And there we'll be looking into 2 components. Number 1, how to set up the routing table based upon all this information we just studied in this lecture. And then, if a packet comes into the router, the gateway, how is it filtered down such that it goes out one of the interface ports? We'll study that in the next lecture. Thank you.